Hi everyone. Um, can you hear? Okay, let's begin. So, today we're going to explore something that might look simple at first, which is called equivalent fractions. But it is actually one of the most important ideas in math. Now, I know when some people hear the word fractions, they immediately get nervous. But today, we're going to break it down step by step using pictures, food, money, and real life examples so it actually makes sense. By the end of today's lesson, you will be able to write fractions from models, understand what equivalent fractions really mean, and confidently tell whether two fractions are equal without guessing. So let's warm up our brains before we begin. Let's take a look at this shaded model. Before we answer this, though, I want everyone to silently think. First, how many total pieces are there in this circle? And then in the second one, how many of these pieces are shaded? Okay, let's continue. So, let's remember, fractions always mean part of a whole. Here's a real life example. Imagine I order a pizza for the class. The pizza is cut into 6 equal slices. If I eat 2 slices, what fraction of the pizza did I eat? 2 out of 6, which is 2/6. So let's look at this model on the screen. Count the total pieces. 1, 2, 3, 4, 5, 6. Now let's count the shaded pieces. 1, 2. Okay, so we have 2/6. The number on top, which is 2, means the denominator. That tells us how many parts there are in total. Think of it like a chocolate bar. If a chocolate bar has 12 pieces and I eat 5 of them, the numerator is 5 and the denominator is 12. The bottom number here, which is 6, is called the denominator. That is the foundation of everything we're doing today. So again, the numerator tells us how many, write this in your notebooks if you want to make notes. The number on top is called the numerator, and it tells us how many parts we have, whereas the bottom number is called the denominator. That tells us how many parts there are in total. So, today our goal is to write fractions from area models. Second, we're going to understand and identify equivalent fractions. The word equivalent might sound big, but it really just means equal in value. For example, let's say I have 4 quarters. Quarters is 25 cents. Or no, instead of that, let's say I have 2 lightweight books, okay? And then let's say in this case scenario, 2 lightweight books is equivalent to 1 medium-sized book. They both look different, the 2 lightweight books versus the 1 medium-sized book, but they are equal in value because both of them have the same weight. So, area models, they look scary. First, you won't be able to understand it, but it is just a picture that shows parts of a whole. The first step is to count the shaded parts. That is the numerator. So let's see here. 1, 2. 2 shaded parts. So we write 2 over here. Step 2 is to count the total parts. That is the denominator. Let's practice. 1, 2, 3, 4, 5, 6. That is the denominator. I want all of you to write this in your notebooks, this chart. That way you can go back to reference it. Okay, now imagine a pan of brownies cut into 9 equal squares. If 4 brownies are eaten, what fraction is gone? Let's break it down. First, the numerator. How many pieces have been eaten? 4. What is the total number of pieces? 9. So 4 is the numerator and 9 is the denominator. So our answer is 4 out of 9, which is 4/9. Now, here's the question. I want you to think about it for 2 seconds. If I cut those same brownies, the 9 equal square brownies, into 18 smaller pieces instead, and 8, not 4, but 8 of them are eaten, did more brownies disappear? I'll give you guys 1 minute to think and then share within your group. Okay. The answer is no. It's the same amount. It is just cut differently. And that idea leads us directly into equivalent fractions. So, what are equivalent fractions? Equivalent fractions are fractions that have the same value but with different numerators and denominators. For example, let's look up here. 1/3 and 2/6. When you first look at the denominator, it might not look the same, but if we go back and if we split the 3 into 6, 1, 2, 3 right here, we would have 1, 2, 3, 4, 5, 6 total pieces. And then for the numerator, that would mean we'd have 2 shaded, which is what we have here, 2/6. So that means both of them are equivalent fractions. To find equivalent fractions, you must multiply or divide both the numerator and denominator by the same number. One second. Let's go back here real quick. Let's say I cut a sandwich in half. I eat 1 piece, okay? I ate 1/2. Now, imagine I cut that same sandwich before I ate it in half into 4 pieces instead. If I eat 2 pieces of the sandwich, that means I've eaten 2/4. Did I eat more sandwich? No, because 1/2 equals 2/4. They look different, but they represent the same amount of food. That is what equivalent fractions are. Let's look at 1/3 and 2/6. Okay? If I multiply the denominator and numerator and denominator of 1/3 by 2, I get 2 over 6. 1 times 2 is 2, and then 3 times 2 is 6. So 1/3 equals 2/6. Imagine folding a paper into 3 equal strips. Now fold each strip in half. Now you have 6 pieces. But the amount of paper hasn't changed. You just folded it differently. That is multiplications with fractions. Here, let's practice. To find equivalent fractions, you must, again, multiply or divide. In this case, we're going to divide. 6/8. If I divide both numbers by 2, I would get 6 divided by 2 is 3, which you can see here. And then 8 cut into 8 slices, and I eat 6 of them, that is 6/8. But if I group the slices into bigger pieces, 2 slices per group, I now have 4 bigger pieces total, and I ate 3 of those groups. That's 3/4. Same cake, same amount eaten. So before we move on, let's practice together. If 1/2 equals 2/4, what would 1/2 equal if I multiplied both the numerator and the denominator by 3? Okay, here's the final answer. 1 times 3 is equal to 3, and then 2 times 3 is equal to 6. So 1/2 equals 3/6. What if I multiplied it by 4? You would be getting 4/8 because 1 times 4 equals 4, and then 2 times 4 equals 8. Do you see the pattern? I hope so. To find equivalent, I said that. However, if I multiply only the top number by 2, let's go back here. If I only multiply the top number by 2 and the bottom number, which is the denominator, by 3, those two things are not equivalent fractions because they're not being multiplied by the same number. Okay, here's an activity. Is it equivalent or not? Can you tell if the fractions are equivalent or not? Okay? So, if you can get into your groups, 2 to 3 should be fine. But for each pair, ask yourself, can I multiply or divide the first fraction to get the second one? If you can, which means yes, then they are equivalent fractions. But if you cannot, then they are not equivalent fractions. Let's walk through the first one. I'll let you work through the first one, and then I'll help you. So now discuss this with a partner. I'll give 1 to 2 minutes. Okay, so let's walk through this one together. First, let's go over here. Here is the answer key, okay? For the first pair, we multiply times 3 equals 6, but 5 times 3 equals 15. But those are not equal. 12 and 15 are not equal. So that means 2/5 and 6/12 are not equivalent. Then we have number 2, which is 3/7 times 6 for both the numerator and the denominator. 3 times 6 equals 18, which is our final numerator there. And then 7 times 6 is 42, which is the final denominator value. For the third one, we have 5/6 times 5. 5 times 5 equals 25, and 6 times 5 equals 30. Since we got 25/30 as our numerator and denominator, that makes these fractions equivalent as well. Okay, before we do the quiz, let's think of a real life scenario, okay? If 4 friends share 2 pizzas equally, how much pizza does each person get? Okay, 2 pizzas divided by 4 people. Each person gets 2/4 of a pizza, but 2/4 simplifies to 1/2. So each person gets half a pizza. Equivalent fractions help us simplify our answers as well. Here's another scenario. If 10 out of 20 students bring lunch from home, what fraction is that? Well, first we would say 10/28. However, we can divide this by 10 by both the numerator and the denominator, which would get us 1/2, which means half the class brings their lunch. But why do equivalent fractions matter? Because in real life, we want simpler answers. Would you rather say I ran 50 hundredths of a mile or I ran 1/2 of a mile? 1/2 is clearer. Equivalent fractions help us communicate better. Now let's go to the quiz. What are equivalent fractions? The answer choices are fractions that have the same value but with different numerators and denominators, fractions that have the same numerator and denominator, or fractions that have the same value and the same denominator but different numerator. I'll give you guys 1 minute to think about it. Okay, so the final answer is, yep. Let's try that. It is correct. Good job. Equivalent fractions do not necessarily have the same denominator, and they do not need to look alike. They represent the same portion of a whole, but they just need to represent the same amount. So today we learned how to write fractions from models, what equivalent fractions are, and how to multiply and divide to find them. We also learned how they show up in real life. Fractions aren't just numbers on a worksheet. They are pizza, they are money, they are sharing things, they're cooking, they are sports statistics, they are real life. Next time you split something with someone, I want you to think, is there another way to represent this fraction? Because now you know there always might be. Great job today. That is all I had for your lesson. It's a little bit shorter than usual, but I want you all to practice understanding equivalent fractions. If you have any questions, please let us know. That way we can help you. Otherwise, that is all I had. Have a great rest of your day, guys.